Hi students, welcome to the video lectures of software engineering. So today we'll discuss about the metrics for analysis model. Okay. So these metrics examine the analysis model with the intent of predicting size of the resultant system. So size is an indicator of design complexity and is almost always an indicator of increased coding, integration and testing efforts. So function based metrics we see. Okay. Function based metric, the function point metric can be used effectively as a means of measuring the functionality delivered by the system. Number of external inputs EI. Each external input originates from a user or is transmitted from another application. Inputs are often used to update internal logic files. So number of external outputs. Each external output is derived data within the application that provides information to the user. So external outputs refer to reports, screens, error messages. Okay, so basically we are trying to focus on the metrics that are applied during the analysis model stage. Okay, so we are applying here to predict what the size and complexity of the system to be built. Clear. So now why the size matters is the larger systems often mean more complexity and higher testing effort, and also sometimes longer integration time. So the key metric is the function point FP. Okay, wherein the function point estimates the functionality provided to the user. So the metrics of analysis model will examine this analysis model with intent of predicting the size of the resultant system. Okay. So number of external inquiries, an external inquiry is defined as uh, number of online input that results in generation of some intermediate software response in form of an online output. Number of internal logic files. Each internal logic file is a logical grouping of data that resides within the application's boundary and is maintained via external inputs. Number of external interface files are each external interface file is a logical grouping of data that resides external to applications but provides information that may be of use to application. So external inputs. Okay, so we come one by one. External inputs, EI is nothing but the data. Let's illustrate this by an example. So EI, that is external input, is the data entered by a user. Let's say login form. Okay, and external output EO is the reports or screen or sometimes the error messages. Okay, then external inquiries, that is we say EQ, let us say EQ, external inquiries. These are the inputs that trigger quick outputs. Okay, so for example, you can take search. Okay, then we have internal logic files. That is, these are some logical data stored internally. Okay, and finally we have external interface files. This is EIF. These are nothing but what? Some external files used by system. Okay, so to understand all these things at a time, let us consider a banking application. Okay, for example, a banking application where login is an input and balance display is an output and the transaction history is an internal file. Clear? Next, metrics for specification of quality. Now we talk about the metrics for specification of quality. So we measure how good is the requirement and analysis documents are. Okay, so these metrics will evaluate the aspects like completeness, clarity, and consistency. So the key qualities that it have are completeness, correctness, understandability, verifiability, okay, traceability, modify, all these things are its qualities. Okay, so like you can just think of it in like you are grading an essay. So we check if it's clear, complete, and free of contradictions or not, right? In the same way. So list of characteristics that can be used to assess the quality of the analysis model and the corresponding requirement specification. Clear? So then metrics for design model. So architectural design metrics. Architectural design metrics focus on characteristics of program architecture. These metrics are black box in the sense that they do not require any knowledge of inner workings of a particular software component. So card and glass define three software design complexity measures. Those are structural complexity, data complexity, and system complexity. Okay. So now these particular architectural metrics will focus on the overall structure. Okay. And how the components interacts. So the calculation is like structural complexity of a module I is defined in the following manner. S of I equal x square out of I, where f out is the number of modules that the current module will call. Okay. Next is data complexity that provides an indication of the complexity in the internal interface of for a module I and is defined as d of I is equal to v of I by f out of I plus 1. Okay. Where is your v of I here is nothing but what? Your v of I mentions number of input output variables. Okay. So system complexity is defined as the sum of structural and data complexity, which is specified as what? C of I equal to S of I plus D of I. Okay. So simply, I mean, next is the more as each of these complexity value increases, the overall architectural complexity of the system also increases. So this leads to greater likelihood that integration and testing effort will also increase. Clear? Then morphology metrics, that is shape metrics. It is a function of the number of modules and the number of interfaces between modules. So size is equal to n plus a, where n is number of nodes and a is the number of arcs. Okay. You can also say um, like number of modules and interfaces as well. Okay. Next, we talk about DSQI. That is design structure quality index. Okay, DSQA is design structure quality index. So from the US Air Force assesses this modularity and data handling using the following, that is S1 to S7 values, which are like modules or count or dependency, database items, all those things. We look into them. So what is the objective of this is this will judge how modular, reusable, and well structured the system is. So US Air Force has designed the DSQI, Data Design Structure Quality Index, which compare S1 to S7 from data and architectural design. So S1 is total number of modules. Okay. S2 is number of modules whose correct function depends on the data input. S3 is number of modules whose function depends on prior processing. S4 is number of database items. S5 is number of unique database items. S6 is number of database segments. S7 is number of modules with single entry and exit. Okay. Then we talk about metrics for object-oriented design. So Whitmire describes 9 distinct and measurable characteristics of an object-oriented design. So first one is size. Size is defined in terms of 4 views. That is population, volume, length, and functionality. Complexity is how classes of an object-oriented design are interrelated to one another. Next characteristic is coupling. Okay. So coupling is the physical connections between elements of object-oriented design. Sufficiency is the degree to which an abstraction possesses the features required of it, or the degree to which a design component possesses features in its abstraction from the point of view of the current application. Next is completeness. That is an indirect implication about the degree to which the abstraction or design component can be reused. Next characteristic is cohesion. The degree to which all operations working together to achieve a single well-defined purpose. That is cohesion. Okay. Next is primitiveness. Primitiveness is applied to operations and classes, the degree to which an operation is atomic. Next is similarity. The degree to which two or more classes are similar in terms of their structure, function, behavior, or purpose. Next is volatility. Okay. Measures the likelihood that a change will occur. That is how likely is it to change. Okay. For example, in the completeness, we have seen the objective of this is nothing but, can the design be reused? So sufficiency speaks, does a class do all it needs to? Okay. Complexity is nothing but how classes will relate. Clear? So all these are the characteristics of an object-oriented design. Okay, next we see class-oriented metrics proposed by Lawrence and Kidd. So Lawrence and Kidd divide class-based metrics into 4 broad categories. First one is size-oriented metrics. Okay, so in this we focus on count of attributes and operations for an individual class inheritance-based metrics. Focus on next individual class. Next, inheritance-based metrics focus on manner in which operations are reused through class hierarchy. Next, metrics for class internal, which focuses on cohesion. Metrics for external focuses on coupling. So first one is speaking about this size oriented, which means the number of methods or attributes. Next is inheritance based, that is reuse through class hierarchies. Then it's about internal cohesion, like are class elements tightly related or not. Okay. Next is the coupling part. That is, are classes over dependent on each other or not? Clear. Next, we have here. Let me write. This is about size oriented. We call it a class matrix. Okay. Size, inheritance, internal cohesion, then external coupling. Next, we have component level design matrix. So here we have cohesion, coupling, and complexity. So what does this speaks? So cohesion is nothing but the functions which are related to the same goal. Okay. Coupling says the dependencies between the modules, and complexity speaks that includes the cyclomatic complexity. Okay. So let me read out again. Cohesion matrix, a function of data objects and focus of their definition. Coupling matrix, a function of input and output parameters, comma, global variables and modules. Complexity matrix, hundreds have been proposed. That is cyclomatic complexity. Next, operation oriented matrix. Okay. So operation size, operation complexity, number of parameters. Okay. What it is saying when I say this operation size, it is nothing but, the lines per method. Okay. We say lines per method. So where we try to keep the operations small and simple from this inference. Okay. So in like this, next we talk about interface design matrix. Okay. So interface design matrix says layout appropriateness, a function of layout entities, the geographic position, and the cost of making transitions among entities. So this is a worthwhile design metric for interface design. Clear? So interface matrix looks at layout. Okay. So primarily this looks out at the layout. Okay. So layout in the sense you see if like how easy is it to navigate? Okay. Or let's say are the entities arranged efficiently or not? Okay. And last but not least is how much user friendly is it? Okay. This is what is important. Next, we talk about metrics for source code. So like after coding, so we can measure the size and complexity directly, right? So that is what it speaks about. So primitive measure that may be derived after the code is generated or estimated once the design is complete. Okay. So the length, the program volume, and volume ratio are given here. Okay. So you can see where this N1 is the total number of operator occurrences. N2 is the total number of operand occurrence. N2 is the number of distinct operands that appear in a program. So metric for testing is given here. Okay. So this help in estimating the total development effort that we have put in. Next, metrics for maintenance. Okay. And before this, you see here there's a program level and effort, where this program level is nothing but we could say a function of code size and complexity. Okay. So that which is given here, E is equal to V by PL. Okay. E is nothing but effort here. Let me write. So program level, that is PL. Okay. So effort is E. So that is equal to V by PL. Clear? Next, we talk about metrics for maintenance. So IEEE standard suggests a software maturity index that provides indication of stability of software product. The software maturity index SMI is defined as this. So where the software maturity index SMI is used to measure the stability across various versions. You can see the equation that is given to derive the software maturity index. Clear? So now, so whenever there is a higher software maturity index SMI, this means more stable release. That is what you have to understand from here. Okay. Thank you, students.